we solve some derivative questions. First question is, if y is equals to 1 plus sin theta plus cos theta whole divided by 1 plus sin theta minus cos theta, then show that this. But here you have to see this, the y is a large term. First you have to change it in a small term, then differentiate it with respect to theta, then it will be easy for you. How to change it? That we using sub-multiply formula. What is sub-multiple formula? First I have to copy the questions. Sub-multiple formula tell us that 1 plus cos theta plus sin theta. I am interchanging the positions. 1 minus cos theta plus sin theta. So 1 plus cos theta means 2 cos square theta by 2. Right? And the sin theta means 2 sin theta by 2 into cos theta by 2, right? And the 1 minus cos theta, that means 2 sin square theta by 2 plus 2 sin theta by 2 plus into cos theta by 2. Here in the numerator we have a common 2 cos theta by 2. We common 2 cos theta by 2. Then cos theta by 2 plus sin theta by 2 left. Same in the denominator, 2 sin theta common. Taking common 2 sin theta, then sin theta by 2 plus cos theta by 2 left. So in the numerator and denominator we get a same term. We cancelled it and 2. That means cot theta by 2. Right? Now we get y equals to cot theta by 2. It's a small term. It is easy to calculate. So differentiating with respect to theta, then dy by d theta equals to the derivative of cot theta is cosec square theta by 2. Because it started with c, we have using a minus, and the derivative of theta by 2 with respect to theta half. So that means we get dy by d theta is equals to minus 1 by 2 sin square theta by 2. Change cosec square theta 1 by sin square theta. So that means dy by d theta plus 1 by 2 sin square theta by 2 equals to 0. That means dy by d theta plus 1 by 1 minus cos theta, the sub-multiple formula, equals to 0. This is the proof. Our question is dy by d theta. So it is easy to solve. So you have to change the large term in a small term. Now come to the second question. Question, if y equals to tan inverse square root of 1 plus t square plus square root of 1 minus t square whole divided by square root of 1 plus t square minus 1 minus t square. Find dy by dt. So it is also a very big term. So we have to change in a small term that you can solve it easily. So here 1 plus tan square, 1 minus tan square. So if we use t square as cos 2 theta, because 1 plus cos 2 theta have a formula 2 cos square theta, and 1 minus cos 2 theta is in a formula 2 sin square theta. So we substitute theta t in term of cos 2 theta. Then it will be easy. So then y is equals to tan inverse 1 plus square root of 1 plus cos 2 theta plus square root of 1 minus cos 2 theta whole divided by square root of 1 plus cos 2 theta minus square root of 1 minus cos 2 theta. We using t square in term of cos 2 theta. So the tan inverse, that means 1 plus cos 2 theta means square root of 2 cos square theta, right? And it is 2 sin square theta. Similar in the denominator, minus 2 sin square theta. So it's easy to get a linear power because square and the square root. So tan inverse, here square root of 2 cos theta plus square root of 2 sin theta whole divided by square root of 2 cos theta minus square root of 2 sin theta, right? So that means tan inverse square root of 2 common and cancelled from up and down, So cos theta plus sin theta whole divided by cos theta minus sin theta. So here we see that tan inverse. So you have to change this term in term of tan. So the answer will be y is equals to tan inverse. We are dividing cos numerator and denominator by cos theta. Then cos theta plus sin theta whole divided by cos theta and whole divided by cos theta minus sin theta divided by cos theta. Because then we get y is equals to tan inverse 1 plus tan theta whole divided by 1 minus tan theta. This is changed to in the form of tan pi by 4 plus tan theta and it 1 minus tan pi by 4 plus tan theta, right? That means tan inverse tan pi by 4 plus theta. That means pi by 4 plus theta. We get y is equals to in a small easy term. Now we have to change theta in terms of t. So theta means half cos inverse t square, right? Half cos inverse t square, pi by 4 plus half cos inverse t square. Then differentiating with respect to t, because we have to find out dy by dt. So differentiating with respect to t, then dy by dt is equals to pi by 4 differentiating with respect to t 0 and it half, and the differentiation of cos inverse t square is a minus because it started with c, so there a minus symbol, then 1 by square root of 1 minus t square whole square, and the differentiation of t square is with respect to 2t, then 2 cancel, minus 1 by t by there are t square root of 1 minus t to the power 4. This is the answer. Thank you.